All right, so here's the last page that kind of summarizes how to graph a square root and a cube root function for a good reference sheet. So the parent function for the square root is y equals the square root of x, or f at x equals that. The domain is 0 to infinity, and that's the same for the range, 0 to infinity, where 0 is included. The end point, and I like calling that the start point, is at 0, 0. So what are some points that we use? So 0, 0, the square root of 1 is 1, and the square root of 4 is 2. So there's the picture of a square root function. It kind of looks like a sideways parabola, but just the top half. What are some examples here of the square root? So first I start with 0, 0. Inside the square root affects the x-coordinate. So the inverse of adding 1, we're going to do the inverse of that, subtract 1. So 0, subtract 1. And then outside affects the y value, and it does what it says, so subtract 3. So that's the end point, or the starting point is at negative 1, negative 3. And then the other points are 1, 1, and 4, 2. So we're going to subtract 1, and into the y's we're going to subtract 3. So 0 and negative 2, and 3 and negative 1. So you can see the domain. The smallest number in the domain for the x is negative 1. From the starting point, and it goes to infinity. The smallest y value comes from the starting point, negative 3, and it goes to infinity. Here again, I start with 0, 0, and I transform it. So underneath the square root, nothing's changed, so it stays 0. Outside the square root, I have two things to look at. So 0 times negative 1, and then add 6. So our starting point is at 0, 6. And 1, 1. So 1 stays the same, but we're going to go 1 times negative 1, and then add 6. So 1 and 5. And then the last one, 4, 2. 4 will stay the same. 2 times negative 1 is negative 2, plus 6 is 4. So 4, 4. And then draw your picture. So notice the negative causes a reflection. So now it's like the bottom half of a sideways parabola instead of the top half. That's what the negative does. The domain, the smallest x value is 0, and it goes to infinity. And for the range, the smallest number is actually negative infinity because of the reflection, and it goes all the way up to 6. So 6 is the largest number for the y. So this is parentheses. All right, let's compare that to a cube root function. Cube root, sine. The domain and range of a cube root is all real numbers, different than a square root. And 0, 0 isn't a turning point as much as it's called a point of inflection. So we'll just call that a point of inflection because that's the right math word to use. That's when the concavity changes. So we have points 0, 0, 1, 1, and 8, 2. And negative 1, and negative 8, negative 2. It kind of, one side kind of has that frown, the other side the smile. Kind of looks like a snake or S, as it kind of slithering across there. So there's the picture of a cube root. So if we want to transform it, by the way, the domain and range never change for a cube root it'll be all real numbers. But 0, 0, look inside, we're going to add 2 to the x, but outside, like in front or behind it, stays the same. So our point of inflection is at 2, 0. We need some other points. So 1, 1 changes. You add 2 to the 1, so it's 3, and 1 stays the same. Negative 1, negative 1. So again, we're going to add 2, and the y stays the same. This may be off my graph, but the other one would be 8 and 2. So 10, 2, so I think it's the last one, and then up. Negative 8, negative 2. So we're going to add 2, so it's negative 6, negative 2. Let's see if I can see this. So I want you to be comfortable with that shape of a cube root and understand the transformation. Underneath the cube root affects the x, and it's the opposite, or the inverse, I mean. If it's in front or after the cube root sign, it affects the y. So the domain is always all real numbers. We have a point of inflection, and it's at negative 5 and positive 4. And then we need more points than that. So if I take 1, 1, I would subtract 5. Here I go times 2 and add 4. So 1 times 2 is 2 and add 4 is 6. So negative 4 and 6. Negative 1, negative 1. So negative 1 times 2 is negative 2 plus 4. Oh, sorry. So negative 1 subtract 5 is negative 6. Then negative 1 times 2 and add 4. That's negative 2 plus 4, which is 2. So negative 6 and 2. 8, 2. So 8 we subtract 5, so it's positive 3. And then 2 times 2 is 4, plus 4 is 8. So 3, 8. And the other one I think is going to be off our graph, but negative 8, 2, so we're going to subtract 5, so it would be negative 13. And again, it would be, that's negative 8. So negative 4 plus 4 is 0. So negative 13, 0, that's off my graph. So let's curve this way and that way, and you can see the curve that we create there. Alright, so that's a good reference sheet in terms of can you graph a square root function and understand domain and range. We start with the parent points. Here, to list the parent points, we have 0, 0, 1, 1, 8, 2, negative 1, negative 1, and negative 8, negative 2. So these are my parent points for a cube root. These are my parent points for a square root. All right, Mr. G Math, over and out.